This is Mr. P from Papapodcasts, and today's video is a special student request. It comes from a question that Sarah sent me asking how to draw the Lewis structure for carbonate, which is CO3 -2, as I've displayed. Well, Sarah, the way it's drawn is carbon is always typically considered the central atom when drawing it. She also asks about how sulfur and phosphorus both undergo what we call an expanded octet. And unfortunately, carbon is not one of those atoms that will undergo the expanded octet. So if you look at the third energy level and on, those atoms have the capability to undergo an expanded octet. And if you notice where carbon is, carbon isn't. And we'll talk a little bit about its location on the periodic table in a moment. So when we're drawing this, we're going to start off with carbon. And carbon, as we said, is going to be the central atom. And we draw the number of valence electrons. So carbon has 4 valence electrons. 1, 2, 3, 4 valence electrons. We're going to draw oxygen, and I'm going to draw oxygen on 3 of the 4 sides of carbon, but in the location where those bonding sites appear. Because these individual electrons are where I like to call bonding sites. And these bonding sites is where the actual bonds will actually exist. So now we're going to draw the valence electrons for oxygen, and oxygen has 6 valence electrons. 1, 2, 3, 4, 5. I'm not going to pair it up here. I'm going to pair it up over on this side. 6 electrons. The reason is because this is where I want to create my my sharing. So I'm going to draw over on this side 1, 2, 3, 4, 5, 6, and over on this side I'm going to draw 1, 2, 3, 4, 5, 6. So now here I have my carbon and my 3 oxygens. However, one thing that I've not accounted for yet is this -2. This -2 means that this entire structure is going to gain 2 electrons. Now, who's going to gain these 2 electrons? If we look at the periodic table is as follows. So we're going to look at the periodic table, and we're going to look where carbon is on the periodic table. So we're going to have carbon. After carbon, we have nitrogen. After nitrogen, we have oxygen. After oxygen, we have fluorine. As we move in this direction, the electronegativity of an atom increases. So the electronegativity of an atom increases. So those 2 electrons, well, let's look at the idea of electronegativity. Electronegativity is the ability to pull or to draw electrons towards the atom. So when atoms share electrons, that electronegativity is going to play a huge role in the direction in which the electrons get pulled. And typically, the higher electronegative, so between carbon and oxygen will have the higher electronegativity. So which means oxygen, one of these oxygens, is going to pick up that extra electron. So let's give this extra electron to, for argument's sake, this oxygen right here that I've drawn in the blue. So there's one of the extra electrons that I'm going to draw, and I'm going to give it to, let's say, this oxygen. It doesn't really matter as long as I give 2 electrons in total to a different oxygen in the structure. So now if I look at my my atom here, my central atom, I've got carbon, 4 bonding sites, right? 4 individual electrons. I have oxygen, this oxygen and this oxygen that gained the electron only has 1 bonding site. So what I'm going to do is I'm going to bond with those atoms to carbon. So carbon now is going to form a single bond to each one of these oxygens. Carbon now has 2 more bonding sites, and look at how many bonding sites this oxygen has. Also 2. So the bond is going to get formed right here. So to simplify this diagram, we're going to draw it as such. Carbon, being the central atom, bonds once to these 2 oxygens, and to this oxygen right here, it's going to form a double bond to that oxygen. And because we have this -2 charge, we will put it in a square brackets and designate that this structure will also have a -2 charge. And there you have it. Here is the diagram, the Lewis structure for carbonate. So hopefully, Sarah, this will be a lot more understandable to you and to anyone else who comes across this podcast. Thanks for watching.